Okay, so the recording has begun. This is day 4, week number 8 of our journey together. And it's definitely a delight to have each and every one of you here. We are going to begin with math. And let me head up properly. So head up with me. We're going to begin. The first subject that we will be dealing with today is mathematics. Today is definitely the Thursday. That is the 25th of August 2022. The subject is, of course, like I said, mathematics. The theme is mathematical concepts. And we're going to begin with section 1 with section 1 is entitled Applying Fundamental Geometrical Principles. So applying fundamental geometrical principles, so that we're going to be talking a little bit geometry today. All right. So applying fundamental geometrical principles, that is the topic for today. So suppose we had this triangle. Let's say we had this triangle here, and let's say that alongside this triangle, let me make it such that its fill is white. Okay, and let's say that alongside this triangle we have another triangle that is connected to it. So let's say that this triangle is here. I'm drawing this one freehand, by the way. And let's say that it's connected such like this. Okay, so we have two triangles. And then we have this line here on this side, and this line is also on this side. And let's say that this letter, this angle we call y, and let's say that this angle we call angle x, and let's say that this is 110 degrees, and this one is z. Okay, so that's what we have. So draw that for me. And the first question is, what if I ask you to calculate maybe I should put it on the other side. So let's reduce this. I'm going to put it on the other side so as to make sure that everything fits on the screen. So what if I say calculate the size of, let's start with the first one, angle x. Okay, so let's say we have to calculate the size of angle X. Okay, so here we have angle X. Okay, notice that angle X is right here. And if you look carefully, it is on a straight line, at least supposed to be on a straight line, with this angle 110 degrees. Does anyone have any idea as to how they would find angle X? Maybe I could ask Taisha Johnson. Do you have any idea
Uh,
as how to
yes, sir. You would subtract. Since the line adds up to 180, you would subtract 180 from 110 from 180, and you get x.
Very good. So this is the first geometrical principle that we'll learn is this one, which says that um, the sum of angles on a straight line equals to 180. So that means that x plus 110 adds up to 180. So if we're trying to figure out what x is, we have to subtract. So that means that x, angle x, is going to be equal to, so let me, one moment. So we're trying to figure out what angle x is equal to. Angle x is going to be equal to 180 degrees minus 110 degrees. And what is 180 minus 110, Albanic?
170.
170? Sure, 170? Or you just saying 70? 180 minus 110 is what? Anyone else want help? 180 minus 110.
70.
70. Yes, 70. Okay, so 70. And so in order to figure what angle x is, right, we subtract 180 and 110. So we find the difference between 180 and 110 because angle x and the angle whose value is 110 degrees should add up to 180 degrees because angles on a straight line add up to 180 degrees. So we have to say because angles on a straight line angles on a straight line at a common point add up to 180 degrees. Add up to 180 degrees. Okay. Okay, next question. So that's I. So how about if we do I double I? So double I asks the question. We still want to calculate the size of angle Y. Okay. So here we need to figure the size of angle y. Now angle y is very tricky. You have to be careful with angle y. Does anyone have any idea as to how to figure out angle y? What should we do? Anyone knows? What would be the size of angle y? Okay. So if we look carefully, Sierra, you have any idea on how to figure out angle y?
No, sir. I think the triangle is 90 degrees.
Well, okay. We know that the sum of all of the angles in a triangle adds up to what?
180.
180. Very good. So one thing we already know from our answer for x, we know that x is 70 degrees. Okay, that is what we know already from the first one. From this first answer, we know x is 70. Now, because we have a line here and a line here, that means that the sides are equal, but that also means that the angles are equal. Okay, so the sides are equal and the angles are equal because we have this line here. Okay, so if this is 70, what must this side also be, Sierra?
70.
That must also be 70. Okay, because we said that the line, the same line, because they have this line here, that means that the sides are equal and the angles are equal. So this is 70. Okay, now we know that all of the angles in a triangle must add up to 180. So y plus 70 all should add up to 180. So the question is, how can we figure out what is y? We know that all of them should add up to 180. So how can we figure out what is y? Anyone want to try? How could we figure out what
Okay,
is?
add 70 plus 70, and we get at subtract 180 from it.
Very good. So we're gonna add 70 and 70 and subtract it from 180 to get what y is. Okay. So the answer for this one is going to be y is equal to 180 minus what? 70 degrees plus 70 degrees. And so y is going to be equal to 180. Jasmine, what is 70 plus 70? Jasmine, what is 70 plus 70? She says 77.
I can answer it.
70 plus 70. 70 plus 70. Go ahead,
It's
Dylan.
140.
140. Very good. 140. I think she probably given the final answer. That's I think the final answer. All right, what is 180 minus 140?
40.
40, very good. So this is 40 degrees. All right, and why is it 40 degrees? Because we know that the sum of all the angles in the triangle must add up to 180 degrees. Okay. Because angles in a triangle.
Excuse me,
Yes, mom.
but how you got 180 though?
Okay, remember we said angles in a triangle add up to 180 degrees. So if we look carefully at any triangle that we have, these angles together all of them must add up to 180 degrees. No matter what triangle that we have, all of them is going to add up to
Okay, figure it
180.
out.
Okay, yeah. Okay. So that's how we get the 180. So because angles in a triangle add up to 180 degrees. Okay. So y is 40. So here y is going to be 40 degrees. The last one that we have to do is we have to do z. So angle I. So I. They say that we need to figure out what, calculate the size of angle z. Okay, so well, angle z is here. Anyone have any clues as to how we could figure out what is the size of angle z? Anyone have any ideas? How can we figure out the size of angle z?
This might
Taisha,
be a question.
say it again.
I say this might be a tricky question.
It's a tricky question. Tricky. Yeah. Okay, so let's look at it carefully. Sierra, what does these lines tell us?
That all sides are equal.
Not all sides. They tell us that the two bottom sides are equal. Okay, you understand that?
Yes, sir.
So this line here and this line here tells us that the two bottom sides are equal. Okay. All right. Since we know that the two bottom sides are equal, that means that whatever this is, this must also be as well. So if this is z, this is also z as well. Okay. So both sides must be z because this line tells us that this side along with this side are equal, which means that their angles are also equal. So if this is z, this part must also be z as well. Okay. Now, we already know that this is 110 degrees, this one right there. We know that this is 110. And we know that everything together must add up to what? Everything together must add up to what? Jasmine, I can't hear you. Your mic is not audible. So when you speak, I can't hear you. But we know that everything together must add up to 180 degrees. But we know that this one and this one is the same thing. So 180, very good. But we know that this one and this one are the same thing. They're the same angle. So whatever this one is, whatever value this one is, this value is also it. So in order to figure out angle z, what we need to do is we need to say, hey, listen, take 180 degrees and subtract it along with 110 degrees. And whatever your answer is, divide it by 2. Okay, that's how we do this one. The reason why we divide it by 2 is because we have to split it between these two sides so that they could be equal. All right, so let's do that. What is 180 minus 110? That gives us what? We saw that before. That gives us
70.
70. Very good. So that gives us 70. And what is 70 divided by 2? That is what? Don't be shy. What is 70 divided by 2?
35.
35 degrees. Very good. Okay. Okay, so let's do a quick recap on the answers that we got. The first thing they asked us to do is to find out angle X. Angle X is right here. Excuse me. And the reason why we got angle X is we said, okay, angles on a straight line add up to 180 degrees. So X and 110 must be equal to 180. So that means that we need to subtract 180 and 110. That's how we got angle X, by subtracting 180 and 110 to give us 70. Now it was time for angle Y. And the way how we got angle Y was that we said, okay, notice that we have a bar here, a line here. We also have a line here as well. So that means that this side, along with this angle, both of them are the same thing. So if this was 70, this is also 70 as well. Okay, so that means we have 70 and 70, but what must Y be? Well, Y, everything add up together give us 180. So Y is going to be equal to 180 minus 70 plus 70, which is 180 minus 140. So Y must be equal to 40. Because if you add up 40, 70, and 70, you get at 180 degrees. And then we come here with this one. We know that this is Z. I'm trying to figure what Z is. But this, we have a line here, and we have a line also where that means that the sides are equal, but the angles are also equal as well. So this angle and this angle are equal. So if this is Z, this must also be Z. Okay? And so in order to figure what Z is, we know that everything together add up to 180. So we have to say 180 minus 110. That gives us the angle that must be shared between the two, which is 70. 70 divided by 2, because they must have the same angle, is 35. Okay, so this one is a bit tricky, like Albanic said, but we are definitely going to do another one of this to so that we can be able to become better at this as well. Okay. Okay, so let's move on, and then we're gonna do example number 1. But really example number 2, because this first one was example number 1. So let's go and we are in section number 1. Geometrical principles. Applied. Okay. All right, so with this in mind, let us look back at our shape. We're gonna again get a triangle. Okay. The shape is gonna be white, obviously. I'm gonna insert a line to be neat. And I'm gonna insert another line that's gonna connect it. Okay. Connect one to the other. Okay. So we have this weight. Okay, and then how much? Let's see. And then we have this next line, which is also weighted. Let me bring it up. So this is a triangle that we have. Here we note that this is here, and this is here, and we also know that this is also here. Give me one moment, please. One moment. Very sorry about that. Let's go. Can you all hear me? Am I audible?
That's all we can.
Okay. Okay, so again, we're going to consider this one. We're going to say that, let's say this one is x. Say that this one is y again. But let's say that this one is a 100 and 30 degrees, and this is z. Alright, so the question is calculate the size of, the first one is angle x, and then we have angle y, and the third one is angle z. Okay. All right, so okay, so Sierra, help me out with the first one. How can we figure out the size of angle x?
Okay, 180. Take away 130.
Very good, 180 degrees. Take away 130. What is 180 degrees minus 130 degrees?
50 degrees.
That's equal to 50 degrees. Very good. So that means that angle x is equal to 50. So this right there is 50 degrees. Okay. All right. Next we have angle y. Okay, now angle y is this one, right? And Sierra, how do we figure out angle y? What do we do?
Okay, angle Y is all should add up to 180. So 50 plus 50, and then subtract 180 from it.
Very good. Because we know that this is also 50 degrees right here. Because if this is 50, this is also 50. Because this line here tells us that. This line tells us that this side and its angles are equal. So this side right here is equal to this side, but also their angles are also equal. So it is going to be 180 degrees minus 50 degrees plus 50 degrees. So it's going to be equal to y is equal to 180 degrees minus 100. What is your answer, Albanic? What is 180 minus 100? Albanic, are you there?
Me?
Yes, ma'am. What is 180 minus 100?
80.
80, very good. Thank you. Okay, then we have Z. All right, so with Z, Deshaun, can you help me with how to figure out Z? How are we gonna get Z?
You say 180
Mm-hmm.
minus 130 over 2.
Very good. 180 degrees minus 130. And we can divide that by 2. So tell me, Dylan, sorry, Deshaun, if this is Z, what is this also? If this is Z, what do we know about this side? Are they equal or not?
I would say equal.
Yes, they are equal because we have this line here, and this line here, which tells us that the sides are equal, but also the angles are also equal. Okay, so this is 180 minus 130 divided by 2, which is equal to what is 180 minus 130? Miss Johnson, can you help me with this? Miss Johnson, are you there? Okay, what is 180 minus 130, Miss Johnson? Okay, I don't think Miss Johnson is there.
50.
Okay, good. 50 and then divided by 2.
25.
25. Very good. Are you there? I was calling you for a while.
I'm sorry, my mic keeps cutting in and out.
I get barely hear you. Say it again.
My mic keeps cutting in and out.
Oh, okay. So 50 divided by 2 is 25 degrees.
You're done?
Okay, so Z is equal to 25. All right, so Z is equal to 25. So that means that this is 25 and this is also 25 as well. Okay, so this is how we go about answering this question. Any questions on this, or it is clear for you? Any questions? Or it is clear? If it's clear, let me know.
It's clear.
Okay. Jasmine, do you understand what happened? Or I need to explain it again?
Could do it one more time.
Do it one more time. Okay, no problem. All right, so let's do it again. So before we do our exercises, let's do another example, a third example. Two notations. Okay, so I move all these from here. So this is example number 3. And geometrical principles applied as well. So again, we have x. We're going to call this y. And this is also z. Here we're going to have 140 degrees. Okay, so, all right, and the question is still the same. We want to calculate the value, calculate the size really. So we're going to calculate the size of the first one, angle x. Secondly, we're going to calculate the size of angle y. And finally, we're going to calculate the size of angle z. All right. Okay. So Jasmine, how can we get angle x? Jasmine, are you there? Jasmine Low, are you there? I'm not hearing from Jasmine. Go ahead, Miss Johnson. How can we get angle x?
Subtract 180 from 140.
Very good. So x is equal to 180 degrees minus 140 degrees. And the answer is 40 degrees. So that means that x is 40 degrees. Okay. That's how much it's worth. That's its size. Now for angle Y, Dylan, how can we get angle Y? Dylan, are you there? Go ahead.
Yes, sir.
How can you get angle Y?
So you're saying one 180 minus open brackets 40 plus 40.
Very good. So 180 degrees minus open bracket 40 degrees plus 40 degrees. Hello, Miss Moxie. Now, if we
Hi,
notice
good
carefully,
afternoon.
hey, good afternoon. So if we notice carefully, Jasmine, are you there? I don't know if you here or not.
Yes, sir.
Okay, good. So if we notice, um, we know that x is 40, but if x is 40, because this is the same side, sorry, this has a line here and a line here, that means that the sides are equal, but also mean that the angles are also equal as well. So this right here is 40 degrees. So this is 40 degrees. And so y, therefore, is going to be equal to 180 degrees minus 40 plus 40, which is 80. And what is 180 minus 80, Miss Moxie?
100 degrees.
100 degrees. Very good. I like that you mentioned the degrees because we are dealing with angles. So y is 100 degrees. Okay, now for the final one, Sierra, help me out with the final one with z.
Okay. Z equals 100, 180 subtract 140 over 2.
Very good. So to get angle z, we have to do 180 degrees. Subtract that from 140. 140 from right here. This is where we get the 140 from. Subtracted with 140. So 140. We're gonna take away 140 from 180 and divide it by 2. So what is 140? Sorry, 180 divided. 180 minus 140. Well, that's definitely 40. And if we divide that by 2, that's gonna be 20 degrees. So that means that this z right here is 20 degrees. And we know that this is z, but Deshaun, what do we also know about this side? Or this angle right here?
That's equal.
Very good. This is also z as well. So if this is 20, this is also 20. Because if we add 140, 20, and 20, all of them should give us 180. So 140 plus 20 is 160, plus another 20 is 180. So all of them should add up to 180 degrees. Okay. And if we look at this side, 100 plus 40 plus 40, 100 plus 40 is 140, plus another 40, that's 180. So all of these together should give us 180, and all of these together should give us 180. So when you finish and you're trying to figure out, did I answer it right? Or what do? You can just check and see if all of them add up to 180. And if it does, that means that you did it correctly. Okay, so that was the third example. Now we're going to move on to our exercise number 1, based on this question. Okay, so let's move on. Okay, sure, no problem. It's recording. So let me exit and show. Okay, so moving right along. Click it. Delete. Okay, so let's do exercise number 1. Geometrical principles applied. So the same shape, but this time you're going to do it on your own. So try it. This is X. This is Y. This is Z. This is $120. Here this is 120 degrees. And so the question is calculate the value, or the sides rather, of the first one is angle X. The second one is angle Y. And the final one is angle Z. Alright, so I'm going to give you 3 minutes to tackle that. And I'm going to begin the timer right now. And the timer has begun. All right. All right, so that's the timer. Albanic, I see your hand is raised, or you lowered it. Okay, your hand is raised. Which one you, excuse me, very sorry. Which one you want to answer?
I want to answer number 3.
Number 3?
Yeah. Angle CPR.
Oh, you want to answer number 3, okay. All right, so Jasmine, are you there?
Yes.
Okay, help me out with number 1. What did you get?
180 minus 120.
Very good. So x equals to 180 degrees minus 120 degrees. So what is 180 minus 120?
60 degrees.
That's 60. Very good. So that means that x here is 60. Deshaun, how did you answer number 2? I mean, angle y for the second one. Deshaun, are you there?
I got answer.
Okay, go ahead.
So you have to say 180
Okay,
minus open brackets 60 plus 60.
very good. So 180. Let's make this better. So y equals to 180 degrees minus open bracket 60 plus 60. So y is going to be equal to what? 180 degrees minus what, Dylan?
Minus 120.
120, very good. Excuse me. What is 180 minus 120? That's what?
60.
60. And if you look at this, right? X is 60, Y is 60, and this one is also 60. So what could we say about this triangle? Anyone know the special name that we give to this triangle?
We could get
Yeah, yes, with a special name.
equal triangle.
Very close, very close, very close. We call this when all the sides are equal. So when all the angles are equal and all the sides are equal, we call it an equilateral triangle. Now you're probably spelling that wrong. Let me go online for the correct spelling. Okay, so equilateral. Oh my god. That's the correct spelling. Equilateral triangle. Where all the sides are equal to 60. Okay. So So this is equilateral triangle. That's a triangle where all the sides and angles are equal. Okay, now Albernic Z.
Okay. So first you take 180, take away from 120.
Very good. So you have to do 180 degrees minus what? 120 degrees. And we do what?
Then we take away and then we get 60 and then we have to divide it by 2.
Very good. We divide it by 2. So 180 minus 120 give me 60 degrees divided by 2. And what is our answer?
30 degrees.
30 degrees. Very good. So that means that Z here is 30. All right. And Z right here is also Z. It's also 30 degrees. Okay. So are we clear on that? Yes or no? Are we clear on that? Any questions on that? Yes or no? Let me know. Don't be shy. Hello, I know no one.
She don't understand it.
Who said? Who said they don't understand it? Say it again.
Alternate.
Okay. So with alternate, the first thing we do is for the first one.
I can't see the bottom.
You can't see the bottom. You can't see the bottom of the other. Okay, so let me put it on top. So we have a Z equals to 180 degrees minus 120 degrees divided by 2. So that's equal to 180 minus 120 is 60 degrees, and 60 divided by 2 is 30. So that's what we have here for at the bottom. Okay, so alternate, the way how we got x was we said 180 minus 120. That gave us 60, because we know that angles on a straight line add up to 180 degrees. The way how we got y was we said 180 minus 60 plus 60, because these two angles are the same. So if you add up 60 plus 60 plus y, you must get 180 degrees. So we said 180 minus 120, which gives us 60 degrees. And for the last one, z, we said 180 minus 120, because this is 120 right here. This is the 120 that we have. So 180 minus 120, we subtract them and we get 60. And when we divide by 2, we get 30. Okay, so that's how we get those answers. Okay, now let's move on to the next question, to the next section rather. Section number 2. So geometrical principles. with parallel lines. Okay. So geometrical principles with parallel lines, that's section number 2. Let's say, for example, we have this shape that we want to draw. So the first one, we have this line here. That's our first line. And hopefully we get it right the first time. Let's make it so weighted. So let's say it's 4. So this is our first line, and then we have another line that goes straight down, that is connected to it, but goes straight down like so. All right, let's connect a little bit more. And then let's say with that, we have another line, say a line that's connected.
Draw that.
Please draw it. A line that's connected here. Maybe I should put this some more below. Okay. And let's say we have a line that goes here. Another line that is also parallel, that is parallel to it, that runs this way. I think this basically sums up what we're trying to do. Okay, close enough. Okay, good. So we have 2 parallel lines, or really one pair of parallel lines. And this line, if we note that this line and this line, they're actually parallel lines because they are going in the same direction and they are the same space apart and they never meet. Okay, so we call them parallel lines. So we look here, this line and this line are parallel lines. Okay, let's call this angle here C. Okay, and let's say that this is 60 degrees. And then let's call this angle here A. And let's say that this is B. And let's say that this one is 100 degrees. So the question here is saying, hey, listen, calculate the size of, let's begin with angle A. Okay, that's the first what's the first one that we want to figure out. So to figure out the size of angle A, okay, so the way we're gonna do this is that I write something right there. To determine the size of angle A, we note that angle A and the angle whose size is 60 degrees are what we call co-interior angles. Now, this is very important. This is a very important part of solving for angle A. When we have co-interior, yes, write it down. Yes, write it down. Whatever I have, write it down. Okay, now look, when we say co-interior angles, this is what we mean. All right. Co-interior angles are basically going to be angles, say something like this, whereby they are, let me see if I can find a better one. Yeah, this is good. So, whereby they are in the same, let me zoom that in, yeah. If we look at H and G, they are co-interior angles. So, they have one parallel line, another parallel line, and they are on the inside of these angles right now. I just say they are on the inside of where this where the transversal cuts the parallel line. So this is on the inside of it, this is also on the inside. And they form a C, all right? So you can see the C that is formed. We call them co-interior angles. So G and H are co-interior angles. Same thing with I and J, right? They are smushed together and they form like a C, okay? That's how you can figure out co-interior angles. Now the thing about co-interior angles is that they add up to 180 degrees. All right, so co-interior angles add up to 180 degrees. So that's what we have to note right here. So that's the thing with this. So to determine the size of angle A, we know that angle A and the angle whose size is 60 degrees are co-interior angles. Co-interior angles I wonder if we put them together. Okay. Co-interior angles add up to 180 degrees. So in order to find the size of angle A, what we have to do is we have to basically subtract 180 from 60. So because they should add up to 180 degrees. Okay, so in order to figure out what is the size of angle A, we say A is equal to what? 180 degrees minus 60 degrees. That's going to be equal to, what is 180 degrees minus 60 degrees, Sierra? That's what?
120 degrees.
That's 120 degrees. So we have that angle A is actually equal to 120 degrees. Now, Jasmine, if we add 120 and 60 together, what is our result? Jasmine, if we add 120 and 60, what is our result? Okay, I don't have from Jasmine.
You say 120 and 60.
120 and 60. What is our result?
180.
180. Very good. Because that's what it's supposed to be, because they are co-interior angles. When we add them together, they should equal to 180 degrees. So that's how we get A. Angle A. We get angle A because we subtracted from 60. So because these two are supposed to add up to 180 degrees. So if we already know that this is 60, and we know that both of them should add up to 180, then that means that we are going to subtract 60 and 180, or find the difference between 60 and 180 to figure out what angle A is. So that's how we get 120. Okay. Okay, next up we have, so that's angle. All right, can y'all hear me? Am I audible? Can you hear me still?
Yes, sir.
Okay. All right, so the next one in the lineup is we need to figure out what angle angle B is. So the next thing is angle B. Okay, so angle B is that. We're trying to figure out how to get angle B. Move this. Any guesses on how to get angle B? Anyone wanna try? Okay, so let me help you out with angle B then. To determine the size of angle B, we note that angles at a point add up to 360 degrees. So that's the trick with angle B. So if we look carefully, right? So that's the rule. So let me show you what I mean. So if we look at angles at a point, so say for example, these angles, if they are angle, so we have 136, 99, 125. If you add all them up, all of them are going to be equal to 360 degrees. That's the difference. They're going to be equal to 360 degrees. So if you have an angle and it's at a point, and we have a full resolution, we know the full revolution is 360 degrees. So if they are at a point, right, they're going to add up to 180, to 360 degrees, not 180. Okay, so angles, or this one say around the point, or you can say angles at a point, all of them add up to all of them add up together to give us 360 degrees. So this, and this, all of them is going to be equal to 360 degrees, because one full revolution, one full circle, one full complete turn equals to 360 degrees. And so if we go back here, we know that what do we have? We have that's my cursor. Okay, if we look back here, we have angle A, then we have angle B, then we have 100, and all of them together must give us 360 degrees together. And so that means that in order to figure, we already know that this is 120, already know that this one is 100. So how are we going to figure what B is, Sierra?
Okay, so 120 plus 100, and then take away that from 360.
Very good. So in order to figure it out, excuse me, we're going to say B is equal to 360 this time. Okay, 360 minus 120 plus 100 that's going to be equal to what? 360. What is 120 plus 100? That's what? 220
Yes, sir.
degrees on these things. Leaving us with 360 degrees minus 220, which is what? That's 140 degrees.
40 degrees.
140 degrees, okay? So a B is actually equal to 140 degrees. Okay. One moment. Give me one moment, please. One moment. Okay, sorry about that. So with B, we get 140. And now the final one, which is how do you figure out angle C? Angle C is probably the easiest one. It certainly is the easiest one in my opinion. So the next one that we need is angle C. I'm gonna put this one right here because we don't have no more space. So let me put it angle C. I'm gonna put it here. So the goal is to figure out what angle C is. So angle C, if you look carefully, right, angle C is directly opposite to which angle? Albanic. Angle C is directly opposite to which angle?
Excuse me, what you say?
I said angle C is directly opposite to which angle?
140?
No. Look at C. It's directly opposite to which angle?
60?
60. Very good. So because it's directly opposite to it, we say that they are actually equal to each other because vertically opposite angles are equal to each other. So C actually is equal to 60 degrees because it's directly opposite this angle that is 60 degrees. So C is actually equal to 60 degrees. No calculations for C. It's equal to 60 degrees. Why? Because if we look carefully, right? If we look at vertically opposite angles, so look at that, look at this. Vertically opposite angles are equal. So take for example, vertically opposite angles. So if we look, excuse me, if we look here, we see that if the angles are vertically opposite, so look at A. A is directly opposite to this angle, so they are equal. B is directly opposite to this angle, so they are equal because vertically opposite angles are equal. Okay, same thing here. If we look at it, these two are equal. They are directly opposite to one another. And look at this. These two are equal. They are directly opposite to one another. So vertically opposite angles are definitely equal. Okay, this is a perfect example here. A and C, they are vertically opposite. They are exactly equal to each other. Same thing with D and B. They're vertically opposite, so they are exactly equal to each other. So vertically opposite angles are equal to one another. All right. So with that in mind, we go back to our question and we see that C is directly opposite to 60. And so that means that C and 60 are vertically opposite, so they are equal. Okay? So with this one, you want to remember that vertically opposite angles are equal.
So, number 3 is 60?
Yeah, C is 60.
Like that, just like that?
Just like that, yeah, no calculations. Okay? Vertically opposite angles are equal. So that's the easiest one of them all because whatever this angle is, this angle will also be. Okay? So, quick recap. Angle A is equal to 120 because that's 180 minus 60. And we got that because we know that they are angle A and 60 are co-interior angles, so they must add up to 180 degrees. Then we go into angle B. Angle B, well, angles at a point must add up to 360 degrees. So all them together must add up to 360 degrees. And so in order to figure what B is, we must subtract 120 plus 100 from 360 to give us 140. And C is the easiest one of them all because C is equal to 60 because they are vertically opposite. So that's our first example with dealing with geometrical principles and parallel lines. Let's consider another example, and we're gonna go through the same thing so that you can get a firm understanding of what's going on. So let's move on. Duplicate. We want to move all of these things. Okay, and we also want to move this. Okay, so let's continue. So draw the same diagram, but this time we're going to have that this one here is 65 degrees. This is angle A. This is 110 degrees. This is angle B. And this one is angle C. And the question is, or the instructions is to calculate the size of first one, angle A. The second one is angle B. And the third one is angle C. And this is, one moment, this is example 2. Still on geometrical principles applied. To parallel lines. Third one is example angle, let's say angle C. Okay, Jasmine, how are you gonna figure out angle A? Jasmine, are you there? Hello, Jasmine, are you there? I'm not able to hear from Jasmine. Okay, how about you, Miss Taisha Johnson? Are you there? Taisha Johnson.
Yes, sir.
Okay, good. How do we figure out angle A? Want me to help you with it?
Yes, sir.
Okay, so say it again, Miss Jasmine. Say it again. I know I heard 180. That's close. Okay.
Two numbers with 180.
No. For angle A, Remember what we did the last time?
Oh, I 110 to 180.
So if when we did, remember what look what we did last time. We subtract. So for this one, in order to get A, we subtract 180 and 60. Okay, that's how we got it. So in this go round, for angle A, in order to get it, we have to say angle A is going to be equal to 180 degrees minus 65. So we, yeah, minus 65. And Miss Johnson, Taisha Johnson, what is 180 minus 65?
115.
115. So in order to figure out angle A, Miss Johnson, you have to subtract 180 from 65 because these two angles are co-interior angles and they must add up to 180 degrees. So A and 65 are co-interior angles, and so they must add up to 180 degrees. So in order to figure out what angle A is, you must subtract 180 and 65. That's how we get angle A. Now, angle B. Sierra, how are we going to get angle B?
Angle B is going to be 115, take away 100.
What? How would you do that?
They add up the truth. I mean, 360 take away 360
Mm-hmm.
take away 115 plus 100.
110. Very good.
Yeah,
So
100.
360 minus 115. So 115 plus 110 degrees. And Dylan, what is 115 plus 110?
225.
You got 225. That sound right. Someone of okay. Oh, hey Deja.
Good day.
I was wondering where you was. I was like, I guess she dishes today.
No, I was out with my mom, and when I finished talking to the lady, I just realized that it was overtime, so I had to rush back home.
Wow. Yeah, we just doing some easy stuff, right, Sierra?
We're
Yes,
doing
sir.
Okay. Just
some
some angles. So first we did let me just quickly snap through so you could see what we did. We did some tricky what should I say? Some tricky problems with triangles and geometry. That's what we did. We have to be careful with them because they are isosceles triangles, and so you have to recognize that these two angles are the same. And so that's what we've been doing for section 1. And then for section 2, we now on dealing with geometrical principles, but this time with parallel lines. All right. And so we are on this question now, and we are actually figuring out what is angle B. And we know that these angles at a point must add up to 360 degrees. So 360 minus 115 plus 110. Dylan told me that 115 plus 110 is 225. Is that what you said, Dylan?
Yes, sir.
And he's absolutely correct, 225. And so What is 360 minus 225, Dylan? That's what. $360 minus 225.
It's 135.
135, very good. So this is 135. 135. Alright, now Albanic, angle C. What is the value of angle C?
65.
65 degrees. Very good. Because they are vertically opposite. Okay, so C and angle 65 are vertically opposite, and like we said before, vertically opposite angles are equal to one another. And so that's how we figure it out. The first one is 115, the second one is 135, and the third one is 65. Any questions before we go on to the third example? Okay, so no questions. So let's dive into the third example and then our exercise. So this is example number 3. Still been dealing with geometrical principles with parallel lines. And when we say parallel lines, we know that this line is parallel to this line. We're going to call this A again. And this time it's going to be dealing with 120 degrees, say. And this is also B. And let's say that this is 70 degrees. And let's say that this is C. And so the instructions remain the same. We want to calculate the size or the measure of the first one is angle A. The second one is angle B. And the third one is angle C. Alright, so Miss Johnson, Taisha Johnson, tell me how we gonna figure out what is angle A.
So subtract 70 from 180.
Very good. Do you remember why we subtracted?
I'm not sure.
Okay. Remember these two supposed to add up to what? 70 and A supposed to add up to what? Can you hear me? They should add up to,
Yes, sir, sorry.
okay, 70 and A should add up to 180. So that's why we subtracted, okay?
Yes, sir.
Okay, because we call them co-interior angles, and co-interior angles are, they sum up to or they add up to 180 degrees. So this is A, which is equal to 180. What is 180 minus 70, Miss Johnson?
110.
110. Okay, thank you. So as soon as we get 110, next we have B. Deja, can you help me with B?
Um, I can't remember this, to be honest. You
What?
want me to help you with B?
B as in boy.
Oh, okay. A is 110. So I
Uh-huh.
guess you just add 110 and 120 and then you subtract it from 360.
Yes.
Okay.
Yeah.
Last time I did this was in grade 9.
Okay. All right. So this is going to be B is 1 to about 360 minus 360 degrees. You know, that was my biggest surprise when I took the Bgcse, you know. Well, one of my big surprise. A lot of the things, when I took paper 1 of the Bgcse exam, I was like, wow, I didn't study this. This stuff I learned in grade 9. And so it was like trying to remember the things you learned in grade 9 and during the exam. Bad idea. Um, so don't forget the things you learned in grade 9. They could show up in paper 1. All right, so don't forget them. So this is 110. Okay, Deja?
Okay, definitely. But I've been practicing the past papers, so I saw it. But
Ah,
I just didn't do angles yet.
okay. So 120 and 110 is going to be equal to 360,
Take away 230.
take away 230. One ten plus 120 is 230 indeed.
And then you get 30 degrees.
30 degrees, very good. So angle B is equal to 30 degrees. Now this is clearly not drawn to scale, because this would not really be 30 degrees, but I think you get the picture. 30, 110, 120. Okay, Dylan, my bad. Deshaun, what is angle C? What is the value of angle C? Deshaun Adderley.
70.
70, very good. And the reason why it's 70 is because C and 70 are vertically opposite, and vertically opposite angles are equal. All right, so then there's that. So that's how we answer this question. Okay, so let's look at our exercise for this, and then we'll be done with this section. If you have any questions, please let me know. If not, we'll move on. All right, so let's go. So this is duplicate. It says exercise number 1 of section 2. So with geometrical principles with parallel lines. And we need to erase all of this. Move that out the way. We still note that this is angle A, and we know that this is angle B. But let's say that this is 125. Let's say that this was 63 degrees. Let's say that this is C. And so the instructions are pretty much the same. We want to calculate calculate the size of of the following, right? So the first one will be, of course, angle A. The second one, of course, would be calculate the size of angle B. The third one, of course, will be calculate the size of angle C. I'm going to give you 3 minutes to answer them, and the timer has begun. All right, that's time. Okay, y'all could have heard my Beethoven music.
Yes, sir.
All right.
Yeah.
Okay, good. That's good. Need some classical music in your life. All right. So, Miss Johnson, Taisha Johnson, how are we gonna answer the first one? Miss Johnson, are you there? Okay, I did not hear from Miss Johnson. Jasmine. Oh,
Oh, I'm
Jas.
here. Sorry.
Okay, go ahead. How you answer the first one?
You subtract 180 from 63
Okay, good. And you remember why?
because of that, so it can add up to 180.
Yeah, they should add up to 180. So, excuse me, 180 minus 63 is what, Miss Johnson?
117.
I could barely hear you. Say it again. Say it again, please.
117.
117. Jasmine, I'm not hearing from you. Are you there? Okay, I'm not hearing from Jasmine. So, I think Albanic have a hand raised. So Albanic, you wanna try?
Okay.
Okay, go ahead.
Okay, so first,
Say it again.
B equals
Mm-hmm. B equals what?
360.
Very good. So B equals to 360 degrees. Uh-huh.
I could do the next one.
Minus, yes, you could do the next one. I think that's Albanic.
125.
125. Because we know that, notice that A is 117, so let's not forget that. So 125 degrees plus what?
Plus 117 degrees.
Very good, plus 117 degrees. That's gonna give me what?
142.
So 360
That's 3
degrees
degrees.
minus 125 plus 117. She said that's 142. And if you look carefully, 125 plus 117 is 242. Yes, 242. That's correct. And subtract, if we subtract them, what do we get? Hello? What do we get? Albernic. Let me subtract them. Hello, Albanic, are you there? What do we get? We get what? 118, 118. It makes me wonder, I think we got this wrong. It's supposed to be 130. It's supposed to be 130. Deja, give me that answer, you know.
Pardon?
It's supposed to be 130, not 30.
Oh, yeah, sorry.
That's fine. Okay. Okay, now, so that's 118 degrees. So please make that correction, people. This is actually 130 and not 30. CR, how could you let me make that mistake?
I probably wasn't even paying attention myself.
Don't let me put the blame on you. That's Deja's fault. Deja,
Huh?
that's Deja's fault, man. Deja, let me put 30.
I don't mind taking fault because I'm not infallible.
It's actually my fault. I should have known better. It just the number just seemed I was like 30. Like, it felt weird, you know, but I'm like, I guess so. Okay, okay, Altonique. What is C? I think Altonique asked her to C.
63.
63, very good. 63. Okay, good. Why is it 63, Deja?
Because you said opposite angles are equal.
Opposite angles. You mean vertically opposite angles?
Pardon?
You mean vertically opposite angles?
Yeah, I was just about to ask you about that. Are we looking from the angle point of view? Because in my eyes, it look horizontal.
Okay, so very good question. The benefits of being here early, right? So earlier we
See?
earlier we saw exactly what we meant when we say vertically opposite angles, and this is what we saw. So vertically opposite angles means that they are opposite when it comes to this intersection. So A and C are vertically opposite, and D and B are considered to be vertically opposite, even though technically they are horizontal, right? But obviously, if we could orient it such that it's vertical. But the idea is that once they are on opposite ends of that intersection, they are vertically opposite and they are equal. So the same thing is true for something like this. We call them vertically opposite. So this is these two are vertically opposite angles, and this is also vertically opposite angles as well. And the same thing applies for this. These two are vertically opposite, and these two are also vertically opposite. Okay, so and vertically opposite angles are always equal to each other. So that's what we mean when we say vertically opposite. Once they are on opposite ends of that intersection, they are vertically opposite to each other. Is that clear, Deja?
Like crystal?
Okay, all right then. Okay, all right. So, good. So that's the end for math. So we, as per usually, we typically are done within 2 sections. So what we did today, we did geometrical principles when it comes to a triangle, and then we went on to do geometrical principles when it comes to parallel lines and looking at notions like this. Okay, so hopefully those 2 principles are clear. Now we're going to move on, transition over to English language. So let's move on to English language. So please head up for me. So today is definitely Thursday. let me head up properly for you. So it's Thursday. One moment, this keyboard giving me some issues. Okay, good, we're right on track. So Thursday, ever since I used this background, I fell in love with it. I'm like, yeah, this is it. So kind of like this one. I haven't changed the color of it yet though. Maybe that'll be nice too, to do that. Let's about this, let's see that. And that's not the same at all, no. Go back, go back. Alright, so today is Thursday, the 25th of August. Maybe we should. Yeah, the 25th of August, 2022. The subject, of course, is English language. And we're still on correcting sentence fragments. Yesterday, we dealt with correcting sentence fragments, but what we did was, excuse me, let me cycle back to what we did yesterday. We did how to correct sentence fragments by adding different parts. So we said, hey, you could correct a sentence fragment by adding a subject as well as a verb. Okay, so for example, for this one, we said, hey, in the ancient tomb. That's a sentence fragment. We corrected it by adding what was missing. So a subject, which was treasure, and found, which is the verb. Same thing with in the morning after breakfast, right? We said Cherie visited the mosque in the morning after breakfast. So we added the subject and the verb. That is one way to correct sentence fragments. Okay. All right. So today we're still on the notion of correcting sentence fragments. We're gonna develop that more today. One moment. Okay, so let's begin. Oh wow, y'all couldn't hear me all that while?
No, sir.
Wow, I've been talking for the longest. Okay, let's try that again. I was saying, the idea here is that we want to figure out which one is a sentence or fragment. So my question to you, Sierra, is which one you believe is a sentence? And which one you believe? Sorry, let's start with number one. Which one is this? Which one is? Sorry, let's start with number one. Do you believe it's a sentence or a fragment?
I recited them. That's a fragment.
It says that I recited to them as part of my as part of my oral report on Egypt. You think that's a fragment?
Oh, that's a sentence
As a sentence?
because it have a subject and a verb.
Okay. Thank you for your remark. Deja, what do you think? That's a sentence or a fragment?
It looks like a sentence because it has a subject, it has a verb, it has a complete thought, but that beginning, though, is that a subordinator? I forget what they call it. Article? They use some type demonstrative pronoun. That's what it is. But yeah, I don't think that belongs in front of a sentence.
You don't
So I think it's a fragment.
think it's a fragment? Okay. Deshaun, you think it's a sentence or a fragment? Where's Deshaun? I'm not hearing Deshaun these days. Deshaun
Sir?
Adderley, yes sir. The
I'm here.
first one. Do you believe that's a sentence or a fragment?
I believe it's a sentence.
I believe it's a sentence. All right. Jasmine, are you there? You believe the first one is a sentence or a fragment?
I think it's a fragment.
I think it's
When he knocked on what?
No, I mean the first one, not the fourth one. The first one.
Oh, the first?
The first, yes.
That's a sentence.
Sitting as a sentence. Okay. So Deja, you're the only one who believe that the first one is a fragment. So
I'm starting to feel, outcasted here, but okay.
so you're gonna stick with that, or
At some point I have to stand for my conviction, so I'm gonna stick with it.
you're gonna stick with it? All right. All right, Sierra. She sticks with her conviction. You think that's a good idea?
Okay.
Think that's a good idea, or
No, it actually, I think I agree with Deja because it say that I recited to them as a part of my oral report on Egypt. What?
I think it's a fragment.
think it's a fragment? Okay.
I see.
Okay.
Okay, so what that sentence trying to say is that they recited their oral report on Egypt to whomever.
That's the thing. You call it a sentence, so you believe it's a sentence then. Deja, you have them thinking, man. If you would
I
just
myself am uncertain.
if you would just change your answer, then everybody would be straight. All right, so let's get rid of the ambiguity. Let's get rid of the ambiguousness, right? And let's get to the point. This is actually a fragment. All right. The reason why it's a fragment is because it says that I recited to
You
them.
don't start a sentence like that.
No, not at all. It says that I recited to them as part of my oral report on Egypt. So it still leave us guessing. So the question is, what exactly did you recite? So like what exactly did you recite? It says that this person recited something as part of the oral report on Egypt, but they still didn't tell us what exactly that is. Maybe you could correct it by saying the class enjoyed the poem that I recited to them as part of my oral report on Egypt. That would be certainly a sentence. Again, the class enjoyed the poem that I recited to them as part of my oral report on Egypt. That would definitely be a sentence then. But as is, it is actually a fragment. And the reason why I deliberately put this is that some people believe that because something is long, it's a sentence. That's not true. Just because you have something that is long, that doesn't mean it's a sentence. So you could have something very long and still like, and you like, oh yeah, man, how did you do that exam? Oh boy, man, I had 600 words, 700 words, and long stuff. Well, that was long group of words, but it was in a sentence. So you have to make sure that not only is it long, but it makes sense. It's a complete thought. So the first one is definitely a fragment. All right, number 2, Sierra. You got a second shot at this. As long as you give yours to, is that a sentence or a fragment?
Fragment.
Fragment. It's a fragment. So everything is a fragment now. Deja, what do you think?
I think it's a fragment too.
You think it's a fragment? So you was right on the first one, so you're gonna take your chances on this one again.
I guess so.
Jasmine, save the day.
Fragment.
Fragment. Okay. Albernique, save the day. What do you think it is?
I think it's a fragment.
I think it's a fragment. All right. Dylan, manpower, save the day. What do you think it is?
Man, I think that's a fragment.
You think it's a fragment? Are you going with the girls? Oh boy. When will men learn to stand for them? Stand their ground. Deshaun, save the day.
Seriously.
Save the day, Deshaun. What do you think that is?
Um, that look like a fragment because
So you side with the
that don't even sound right, honestly.
So you side with the girls as well.
Oh my goodness, man, Mr. Petite, man.
My. Okay, so this is actually a fragment. Okay, all right.
Okay. Exactly.
It's actually a fragment.
So what you were saying earlier about take it up for the girls or something like that.
Sometimes they're right.
Come on, Mr. Petite, explain that, man. Come on.
Sometimes they're right. Sometimes they're right. Okay, so as long as you give yours to, that's actually a fragment. Maybe we can correct it by saying, I'll give my report today as long as you give yours too. That would be a sentence. So once again, I'll give my report today as long as you give yours too. That's a sentence. Okay, but as is, this is definitely a fragment. Number 3, the necklace that you described has been found. Sierra.
Sentence.
As a sentence. She says a sentence. Deja.
I agree with Sierra.
You
Sentence.
agree? Okay. All right. Jasmine, what do you think?
Sentence.
Miss Johnson is.
Everyone counting on Sierra with
I
this
know, right?
answer.
Everyone count on Sierra. Sierra saved the day, I guess. All right. This actually is a sentence. And Deshaun, what do you think for the fourth one? I opened the door when he knocked.
That's a sentence.
Most definitely, it's definitely a sentence. Okay, so okay, now I'm gonna add 2 more, and then we're gonna leave. Excuse me. The fifth one says, which has, this one is for Deshaun, an average temperature between 55 degrees and 70 degrees. in the cool season. And the second one is the sixth one is who we thought were both friendly and polite. Who we thought were both friendly and polite. Okay, so go ahead, Deshaun, with number 5. Is that a sentence or a fragment? Deshaun, are you there?
Yes, yeah.
Okay, so number 5, sentence or fragment? Oh, you're thinking on that one.
Let's just look like a fragment to be honest with you.
Look like a fragment? Interesting. Sierra, save the day.
That's a fragment.
That's a fragment. Say that very confidently. Deja, what do you think?
I agree. It's a fragment.
Think it's a fragment? Okay, Jasmine, what do you think?
It's a fragment.
It's a fragment. Okay, Dylan, you think it's a what? Okay. And let's look at it. It is actually a fragment. And this is actually the longest group of words here, but it's still a fragment because of how it starts. This is not a sentence. Now, maybe if it has had a question mark, yeah, then it would have been a sentence. It was actually asking a question. But here, as is, it is missing something. Okay, so we can say the Sahara. You can't say the Sahara Desert. We can say maybe we can say the Philippines, which has an average temperature between 55 and 70 degrees in the cold season. We need a place, right? Like what you're talking about has an average temperature, all right? So we need the place. Like what exactly? Where are you talking about? Okay, so we need the place. Still missing some information here. All right. Number 6, Deja. Who we thought were both friendly and polite is what?
Fragment.
Definitely fragment. Okay. All right. So with that, we're gonna end. Just a major announcement. Today is the last. Please listen to me carefully and do not misunderstand me. Please do not misunderstand me. Today is the last day of summer classes. I didn't say today is the last day of classes because the last time I made this announcement with my other class, they go on and tell their parents today is the last day of class. Today is not the last day of class. It is the last day of summer classes. Summer classes. So we finished full 8 weeks of summer classes. Right, that was 8 weeks. Anyone was there from week 1? Like
Me.
Sierra, Jasmine, wow. Okay.
I think I was there too.
Okay. So y'all are the OGs, right? Yeah. So this is the last day of summer classes. Next week, Monday, we begin fall. Fall is gonna be a bit different. For one, there are gonna be more people.
That's the day when I am school.
Yeah, yeah. Yeah, for one, it's going to be very different. So you're going to have the challenge of leaving from school and coming to school. And not only you, but also me. So I also begin school um, on Monday. Obviously, I'm not a student. I may sound like a student, but I'm a student. Um, yeah, I have the mighty task of teaching those students. Boy, yeah, pray for me. But yeah, so me and you will be leaving from school and coming back to school. So it's gonna be a task. So that's the first major change. Um, the next thing is that with fall classes, it's a bit different because um, Monday and Wednesday is the only day that we do English. So Mondays and Wednesdays are the days that we do English. So we'll go from 6 to 8 with math and then 8 to 9 with English. And we end at 9 o'clock. I know some of you've been like around we've been ending around 8:30 thereabout, but we end at 9 o'clock on fall. So it'll be from 6 to 8 for math and then 8 to 9 for English. That's only for Mondays and Wednesdays. And then on Tuesdays it will be health science and general science. That'll be after math. So math every day we have math 6 to 8. But if you're doing health science and general science, then you'll stay back for 8:30 and 9:30. If not, then you could leave. Then Wednesday we do um, math from 6 to 8, and then English from 8 to 9, and then on Thursday we do math from 6 to 8, and then social studies from 8:30 from 8 to 8:30, then religious studies from 8:30 to 9. So if you're not doing social studies and religious on Thursday, you can leave at 8 o'clock. So that's the difference there. Um, and fall, we only have 17 weeks in fall. So we have to make every week count. And so come ready to learn, come prepared mentally, and come prepared to see new faces. Well, you can't really see them, but hear new voices, and to make the class, a little bit more lively. But also come with a ready mind and a willing spirit, because your exams is in with about 37 weeks from now. About 37 weeks from now. So 17 weeks in fall and 20 weeks in spring. So that's the only time we have. And so every week matter and every day matters. So please come with a spirit willing and ready to work. And if you have any questions, please let me know. Make sure that you are turning in those class notes. I'm going to be very pet peevish come fall for those class notes. All right. So enjoy your break. The rest of the summer that you do have, and we come back on Monday to begin fall classes. So all the best. Do well with your regular classes in school. Put your best foot forward. Please do. This is the only time that you have, or treat it as if it's your last. All right. So all the best, and I'll see you on Monday. God spare life. All right. Take care. All right. See you. See you. Take care.
Take care.
Yes, sir.
I have a question.
Go ahead, Deja.
You said you're doing general science and health science and religious studies. Are these BJC or BGCSE?
No, definitely BJC. So if you already finished BJC, you could leave. You could leave at 8 on Tuesday and Thursday.
Okay.
The only thing that might be valuable for you would be religious, because are you doing religious BGCSE?
I have to.
Yeah. So I mean, that's a given though. You're Adventist, so I don't see you.
I'm not. I told you I'm basically a vagabond. Religious vagabond, that is.
Oh, Lord have mercy. Please, don't say that out loud. But you should know, when the last time you've been to church?
Oh boy. Probably, boy, months ago. Months ago.
What church that was?